Okay, so initially on this one, if I was going to start with a sketch of some sort, I'm going to look at graphing g of x. That's the parabola. It looks easier to graph. I'm going to start that one in blue. I can see right away that in g of x, I could factor it. And so I know that at minus 2 and 0, I have x-intercepts for g of x. And it's a parabola that opens up, so it looks something like this. I'm going to graph f of x in green. I also notice that f of x factors nicely. Ooh, with the same factors of -2 and 0. And I'm going to use my grade 12 skills to graph this because I don't want to do all the calculus right now to graph everything. So what would that mean? What would that look like? Well, the green one is an x cubed graph. So I know that its end behavior looks like this. It's going to be starting down here and ending up here. I also know that at 0, it has a multiplicity of 2 and is going to bounce. So my graph here looks something like this. And I want to find where these two graphs, and I find the area between the two curves. It looks like in my sketch that there's a possibility of 2 parts. Did anyone bring crayons? All right. One thing teaching has done over the years is prepared me for disappointment. We have that purple section, it looks like, and this orange section here as the area between two curves. That's just based on my sketch. I'm going to find out more if this is true when I find out where do these two graphs intersect. Now, from our quick sketch, we already found 2 points where they intersect. I'll label them here and here because they share those same x-intercepts. But if we wanted to see all the places they intersect, we need to solve where they're equal to each other. So I make x cubed plus 2x equal to x squared plus 2x. X cubed plus 2x squared. Yes. And combine my like terms, bring everything over to one side. So I'm going to have x cubed plus x squared plus 2, or minus 2x equal to 0. I can factor out a common factor of x squared plus x minus 2. And this factors nicely. We'd already found these two answers, but now we find out that they also intersect at x equals 1, which apparently is this point right here, nicely to scale at 1, 3. So there are 3 points where they intersect, and based on our diagram, we notice that sometimes the green graph is on the top and the blue graph is underneath, and the other time the blue graph is on the top and the green graph is underneath. So we're going to have to find these areas separately. The reason we have to do them separately, let's say you just went from -2 to 1, and you did the green one minus the blue one. If you do the green one minus the blue one, this purple area would be positive, but this orange area would be negative because the green one's underneath. So we have to set this up as the integral of from -2 to 0 of the green function, and the green function was x cubed plus 2x squared, subtract the blue function, x squared plus 2x, dx, and then we're going to have to add the integral from 0 to 1, and this time we'll have the x squared plus 2x first, and subtract the x cubed plus 2x squared, dx. Simplifying this first will give us, in the first one, x cubed plus x squared minus 2x dx. And the second one simplified will be 1 negative x cubed minus x squared, and then plus 2x dx. And it should make sense that when they're simplified, one would just be the negative of the other one. I mean, if you wanted to do it quicker, you could just do that. Look at your first answer. If you're convinced you got it right, multiply it by a negative, and you have the second one. This will be x to the 4 over 4 plus x cubed over 3 minus x squared. And even the integral is exactly the same, just with the negatives there. So we plug in 0. This will be 0. Guess I left way too much space for that. Then we plug in negative 2. This will be negative 16 over 4. No, positive 16 over 4. 16 over 4 minus 8 over 3 minus 4. And then here, plugging in 1 will be negative 1 over 4 minus 1 over 3 plus 1. And plugging in 0. Very nice. Probably what I would do in this situation is I would put my fractions together that already have common denominators. So I'm ahead of time thinking this negative is going to distribute everywhere. So I'm going to have negative 16 on 4 plus a negative 1 on 4 will give me negative 17 on 4. 8 on 3 minus 8 on 3 minus 7 on 3. And 4 plus 1 plus 5. And then from here, we would have to get a common denominator to do the rest of it together. So I pick a denominator of 12. Something seems wrong. What went wrong? Because we're going to get a negative answer right now. Did I forget a negative somewhere? Did I subtract wrong?
The 8/3, that has to be positive. If you're subtracting 1/8, to be positive 7.
Oh, there it is. This will be, yeah, I put the arrow there and everything. This will be 8/3 plus, that'll be plus 7/3. There we go. Again, something that tells you you've made a mistake. I'm getting an area. My area should be positive. My area was going to be negative. Something went wrong. Problem is when you make a mistake, sometimes it can take a long time before you find out where that mistake is. And so the recommendation is not to try to go too fast at any point. It's a balance. Because you want to go fast enough that it doesn't take forever, but not too fast that you make a mistake. And so you want to go as fast as possible without making mistakes, which you will always try to go faster than that. And then you will make mistakes. Anyways, when we put this together, do we get 37 over 12? Did that fast. And we get that as an answer. Now, we could do this same thing on a calculator or on decimals. So what would it look like if I graphed it on my calculator or I graphed it on decimals and wanted to find this same answer? Okay? So first of all, I'm going to graph the x cubed plus 2x squared in one graph and the x squared plus 2x on the other graph, and see what we saw from before, the two shaded parts. Okay? Now on your graphing calculator, you can go to the calculate button above the trace button, so second calculate, number 7, the integral, and we'll start at -2 and go to 0. That'll shade, wait. That just shades the top part because it just did the blue one. So one of the things we can do now as well, which is kind of cool, is you can do this one minus this one. But instead of rewriting the whole thing, we can write it as, I wanted to color everything in, but it's not going to work that way. We can do it as follows. So we can go to our variables button and over to y variables, and then they have all these y1, y2, y3. So I can just go and say, I want to do y1 minus y2. So you get them under variables. You can also, if you have the alpha menus and going across them, sometimes they appear in the variables. That's probably the easiest way. Alpha, and then the fourth one to get your variables. And you can do the two subtract each other. So what that will do, okay, now if I go to the graph, that gives me that black part of the graph there. And if I want to find the integral number 7, this is also a little bit tricky on your graph, because right now it's on the blue graph. Now it's on the red graph. Now I'm on the black graph. So I can go from -2 to 0 of the black one, and it filled in that black part, and that black part would be the area between the two curves in that section, and we get 2.6 repeated. Two and 2/3. If I want to find the area between the red and the blue here, I could either do the same thing and calculate the integral on the black graph, so I'm going to make sure that I'm highlighted on the black one, from 0 to 1. And of course, at this point, it will be negative because it's below, because I'm doing the wrong order if I do y2 minus y1. But if I just take that answer, 0.41667, and add it to this, then I'll get the final answer. Interesting thing, sometimes this will work. The last thing that you solve for on your graphing calculator, if you go second answer and push enter, you move it to this screen, which can be really nice, especially because right now I was curious what this was as a fraction. It's 5/12. So I had 2 and 2/3. I can now say I'm going to add 5/12 to that. This, of course, is 8/3 and 8/3. It's going to be 2/12 plus 5/12 is 37/12 as well. Desmos will probably be even more intuitive, okay? And in Desmos, if we go, to Desmos, and we type in our functions, f of x. So sometimes in Desmos, if you want to do something, and in this, usually you can do it. So what I'm going to try here is I'm going to write the first function. I guess it was a plus sign in between. There we go. And I'm going to write the second one as g of x equals, and we had x squared plus 2x. Those are our two graphs. Okay. There's probably a nice way to do area between a curve. I'd really like to know that, but I don't. So I'm going to do the integral, and you just write integral, from -2, to 0 of does that work? No. Why doesn't that work? So I'm like, well, it's a computer. You can copy and paste. That's probably just as easy. Do I have to put this all in brackets to do the dx? Yes. So if you type it in, it calculates it for you. Something really cool in Desmos, if you put in letters here, A and B, it says, would you like to add sliders? You say yes, and then you can just make it go from -2 to 0. And it calculates it. And then you say, oh, and then next I want to check from 0 to 1. And it calculates that as well. So something fun to play around with on Desmos.